Hey, what's going on, everybody? Welcome to Canvas RPG Kit Extended. This is the second part of a series I did about making JavaScript RPGs on my channel a while back. If you saw the first part on the same YouTube channel, this will pick up right where that left off. Here's exactly what we're going to cover in this video. Here in part 2, we're going to start by changing the current level scene, so you'll be able to enter a cave area by stepping on this exit space. You'll be able to use this concept to connect new rooms and worlds however you want. We'll then add some NPCs to the screen. We'll cover 2 different methods for implementing text boxes in HTML Canvas games, including a nice typewriter effect for the dialogues to feel like speech. We'll also put character portraits in the text boxes so you know who you're talking to. We'll end with a lightweight story flag system so NPCs can say or do different things based on what you've already done in the game. I'll have timestamps for each section in the description below. If you like this kind of stuff, consider hitting like and subscribing to the channel. That just helps me out. If you're working on a game or you're interested in working on a game, you should join our Discord server. It's a friendly community full of other people making video games. People of all different skill levels, all different technologies are in there. Be sure to check that out too. The link is in the description below. There's also other links in the description that you can check out for more support. Okay, well, let's get into it. This is Canvas RPG Kit Extended. In this section, we're going to add an exit game object. This is eventually going to be our collision trigger for changing levels. Now, we are about to start the process of letting the hero change maps when he enters a certain space. So we're going to be dealing with a couple new things of art in the repo. In this section here, we're going to focus on adding this staircase object to the map. That's kind of like what it looks like zoomed out. It looks like a staircase. Soon after that, when the hero steps on the staircase, we're going to switch this whole area out to a level that looks like this. See, it's like purple, it's the cave level. And then we also have a dedicated background for that cave level too that's gonna replace our sky here. So let's get started by focusing on getting one of these stairwells in the map. Worth noting that I've added these assets to the project, cave PNG, cave ground, and exit. Let's go to our resources file and make sure that each of these get loaded into the browser. So first is our cave. Then we have our cave ground. Then we have our exit sprite. And I'm gonna do a little bit of rearranging in the order just for cleanliness. So these two are kind of like our outdoor level. Exit can kind of go up here with different objects. Let's go into our objects directory, make a new subdirectory, and that's gonna be called exit with a capital E. In that new exit directory, let's make a new file called exit.js. And this is going to be a lot like our rod. If we look at rod for a second, just to reference it, it's a game object that just has a sprite, and it's going to be listening for the hero to collide onto it. We're going to copy over a lot of these same ideas, but we'll do it from scratch. So first we'll export a new class called exit, and that extends game object. We'll give it a constructor. That's going to take in an X and Y. Our super call will pass through a new position, which is a new vector2, using our X and Y. We'll add a child, and then right in the parentheses there, we'll say new sprite. The resource for this sprite is going to be our resources.images.exit, which is that stairwell sprite. That's 16 by 16 by default, so we don't need to put in any like custom sizing or anything like that. It's just gonna work like this. Let's go to our main scene and add one of these. So we'll go kind of just above the hero. Exit is a new exit space. And I'm gonna copy over the grid cells that we used for the hero and then kind of change them. So the X is fine. Let's put it higher up on the map, like 3 or so. And then we'll take our main scene and add our exit. Add child exit. Now we see it rendering on the screen. So far, so good. Heading back to the exit, let's go ahead and extend our ready method. As soon as the exit object enters the scene, it wants to listen for that same hero position to know if the hero has stepped onto it or not. So we'll go to rod and actually kind of copy this over, because it's more or less the same thing. We want to round the hero X and Y and then compare it to our position X and Y. The only thing we don't need is this on collide with hero. Instead, for now, let's just console.log hero enters the exit space. Now when I enter that space, we get our console log happening, so that's working great. Now, instead of this really directly doing anything, we want the exit to sort of just emit upwards a signal, like, hey, the hero is here, someone else do something about it. So for that, we're going to emit a different event. So we'll grab our events and run the emit method. We'll call it hero exits. For this particular type of signal, we don't really need to provide a value. We just want to know that this happened. So there's no need for us to provide something here. We'll just leave it empty, clean this up. Now let's go to the top level in main.js. And currently right now, everything's kind of baked into this main scene. That's where we add our ground and our hero and our camera and rod and even our new exit. We're gonna unwire a lot of this and make the level composition a little bit more swappable. But for now, let's just kind of demonstrate what it looks like to listen for that hero exiting signal. Down here before the update code, I'll say events on hero exit. We can say the main scene is listening. Change the map, just as a console log. Hero exits. Now when the hero enters the stairwell, we get the change the map signal. So now we know at this top-ish level, we're gonna be able to take all of these things like the ground scene and the sky and the walls and swap them out with something else. Like I mentioned though, to do that, we're gonna do a little bit of unwiring first to make the whole thing a little bit more sustainable. So let's keep going. In this video, we're gonna wire up our exit to change the level that's loaded. Okay, let's start moving some of this level specific stuff into its own home. Now we already have a directory called levels and we're gonna keep that, but this file that says level 1 that has our walls in it, I'm gonna go ahead and rename it. So we will rename this file to outdoor level 1. Now I'm gonna comment out everything in here for a second and that's gonna cause some havoc. Things will get pretty broken on this one until we come out on the other side, but that's okay. Now, instead of just having the values of the walls here, we're gonna end up with something that's a little bit more like export a class that's our specific level name. Like we could call it outdoor level 1. And we could extend a game object for that, just like we've been doing, but we wanna extend a pretty specific type of game object, one that really knows everything about what a level is. So instead, I'm gonna say extends level here. And now this doesn't exist yet, so we're gonna create it. I'll go into our objects directory, collapse all these, make a new subdirectory called level with a capital L. Right inside there, we'll make a new file called level, capital L again, .js. And here we're gonna export a class called level, and that's simply a game object. But again, it's gonna be a really specific type of one. So we'll give it a constructor. Let's go back to our outdoor level and just make sure that the correct type of level is being imported. So I'll import level. Now everything's wired up, right? You remember in main.js how we have some drawing code and it's kind of just drawing the sky sprite directly. And then later on, it's also drawing inventory directly. Instead of just doing direct actions like this, we want to provide a little bit of a hatch. So the sky sprite is actually going to come from the current level that's loaded, and the specific level will be the outdoor level. That's what we've been looking at so far. And we'll also have a hatch for drawing stuff on top of the world, like the HUD and the inventory and all that. But we're not quite ready to add this one hatch yet. Instead, we want a level between main.js and outdoor level. Remember at the top here, we kind of make a new main scene that's just a vanilla game object. Let's go ahead and create a pretty specific type of game object called main. Main is going to be the real manager of the whole game. It's going to get mounted when we start the game, and it's never going to leave. Okay, so one last bit of setup before we can really start moving everything around. In objects, we'll make a new folder called main with a capital M, and then right inside here, capital main.js, not to be confused with lowercase main. You can also call this game with a capital G or something like that, but I like the convention of sticking with main.js, which many game engines do. So we'll export a class called main, and that extends our game object. We'll give it a constructor, Now currently in the top level file, we have all of these things like creating the sky and the ground. We know those are going to move into a level. We also have these more global-ish things like a camera and inventory. So we want those things to move into our main scene. First, I'm going to slot out a space for the level to go. So this.level, we'll just start at null. We'll populate it right away, but for placeholder's sake, it's null. Then we can make one of those input classes. That'll be a new input. That's the same thing that we did in main.js, and so we can go ahead and remove that one. There it is, how we tack it onto the main scene there, the temporary main scene. Let's go ahead and delete that. We'll do a similar idea for the camera. That's a new camera. And the inventory. We're going to make a setting method for that level, and that's going to take in a new level instance. We'll get back to that in a second. Finally, we want to provide those two drawing escape hatches. So I'll say draw background is going to be one dedicated method, and that can take in the context. And then we'll say draw foreground also is kind of a reverse-ish, and that'll also take in the context. In our top level file, instead of saying sky sprite.draw main image, let's go ahead and say main scene.draw background, and we'll pass in that context. It's unhappy for a second because we haven't actually made main scene a instance of main yet. We'll do that in just a second once we get our hatches going. So we can remove that manual draw, and same thing here. We'll remove this line and say main scene.draw foreground, passing through the context. Let's go up to where we define that type of game object. Again, instead of it just being like a vanilla one, we'll rename it to be new main. And now if we look down here, the autocomplete should be happy. Back in our main drawing hatches, you can see these are lit up and being used now. We'll go ahead and bring back those drawing instructions. So if we have a level loaded, so this.level, optional chaining, if this is null, like we don't have a level, like we haven't set one yet, it'll just stop. But that level is going to have a background. That background will be a sprite, just like the sky sprite that we've been dealing with so far. And we can go ahead and call the draw image method on that sprite. We're creating an instance of an inventory up here, and so we can do the same idea down here. So this.inventory will fire the draw command, passing through that context, and then the inventory's X and Y, which remember, when we create that, it gets nudged a little bit. Okay, now level is going to have a background, right? So let's go ahead and fill that out. We'll go to our dedicated level class and say that this.background just starts as null. But in our outdoor level, we know we're extending level here. So we'll make our constructor. A lot of little moves happening here, but it's all going to come together quick. We can say this.background is going to be one of those sprites. So we'll go to our top level file where we created the sprite before, sky sprite. We'll move this idea into our outdoor level. Let's go to our hero real quick. And remember, it's trying to import these walls, but those don't exist yet. So we're going to remove that line. And then we'll remove that same line from the top level main.js. In fact, we can remove all these unused things. Usually do that as I go, but you know, I got carried away here. Cool, so now we see some stuff on the screen. We don't see our sky yet though, and that's because we're still kind of manually drawing this business here. Let's go ahead and do a little bit more cleanup. We're not using this top level inventory anymore, so that can go away. Camera is the same idea where main.js, the new one, internally creates its own camera. So we don't need to do that from the outside anymore. So let's get rid of that. To fix that error, we can come down to our loop and just ask if our main scene has a camera. We'll go ahead and surround that in the if. And then draw directly from our main scene's camera. Now we're up and running again. Now these things that are manually getting added to the main scene are really not part of the main scene anymore. They're part of that outdoor level. So let's move them there. I'm I'm going to take all of these lines and copy them and delete them. I'm going to go ahead and delete the sky sprite part because we already moved that over. In outdoor level, we're going to kind of build up the content of this room or this level. So I'm bringing over those same lines, but instead of main scene.addChild, we can just change this to this.addChild. So now all of these objects are children of the outdoor level. Our main game object here has this method for setting the level, and we're going to kind of fill that out now. First, we have a slot for level ready to go. So we'll say this.level is that new level instance that will get passed into this method. Then to make sure that the drawing loop and the updating loop and the delta time and all that stuff is flowing through the contents of this level, we need to go ahead and make sure that that level is a child of our main game object. So we'll say this.addChild, this.level. Now, believe it or not, the session is all about switching levels. So if we already have one, we want to make sure that we destroy the old one. So if we have this.level, we're going to run this.level.destroy. And remember, our destroy method is going to iterate through all the inner content and remove it all and remove any bindings and events and that kind of thing. So if we didn't do that, we'd have two levels running at once. Let's see what happens when we actually run this method. So in main.js, as soon as we create our main scene, we'll run main scene.setLevel, and then we want to pass in a new outdoor level. So that's going to spin up a brand new instance of our dedicated outdoor area. And now everything is rendering as it was before. Now, very quick recap, because we made a lot of moves there that went from totally broken back to semi-working again. Basically, all we've done is move all of the content from the top level main.js into a dedicated level. That level is called outdoor level. It extends a more generic type of level that's really just a game object that takes in a background. As we add more features to the game and there's more level specific stuff, we could probably build out this base class, this base level class, into doing more level savvy things, or just don't really need them yet, but in the future we might. So that's a good home for that. The outdoor level is then going to add all of its inner content, like the background it wants to use, the ground sprite, the rod, the exit, all that stuff. That happens in this dedicated file. So the idea is that we can now have a different level file. Like here's our outdoor one. We could have a cave level. That's what we're going to do next. You could have all kinds of different levels. It's just a matter of grabbing our main scene and calling set level, passing in a new instance of whatever that next level should be. Now we are missing one thing, I believe. Yes, as soon as you try to move the hero, we'll see a runtime error happens. Walls is not defined. That's because we need to change the wiring a little bit to look for walls on the current level. So remember our outdoor level, we have these commented outlines here. I'm going to copy them all and bring them back in. We can bring them back in at the bottom of the constructor here, uncomment them out. Instead of exporting a const, we'll just say this.walls is a new set. And then change it all to this.walls. Fix the formatting. Now walls are set up to be internal. And remember, just as a reminder, these values should match the image that's being used. So this particular image has clear kind of things that look like blockers. So we manually place the positions on top of those, like the rocks too and the water. We've got just a handful of them ready to go here, but you of course would tweak these for whatever art you're bringing into the project. Now our hero is still kind of looking for a willy-nilly top level walls to be used. So where we check for it is space free. We have access to our root here. We can pass through our root.level.walls. Now when the hero moves, the wall blocking is back in place, so I can't move on to the water, so that part is restored. Our last bit is to wire up this stairwell to actually switch to a new level when this change the map signal fires. Before we get into the changing, let's go ahead and just create the new map and boot up the game starting with that new map instead, so we can kind of see something different. A good way to do that is often just to copy everything and rename things, but we'll go ahead and start from scratch just to demonstrate everything. So I'll create a new file called cavelevel1.js. It's going to export a new class called cavelevel1, and that's going to extend level. In our constructor, we want to make sure that we have walls. That'll be a new set. We can fill those in later. We want to make sure that we have a background, and that's going to be a new sprite. We can take a look at our outdoor level. Remember that we provide a resource and a frame size. Frame size is going to be the same. It just matches the size of our canvas. So I'll copy that line over. For our resource, I'm going to say resources.images.cave. And remember, we added that to our resources.js file, so you should see it right here, cave and cave ground. Speaking of cave ground, we'll say ground is a new sprite. Same idea where the ground is also sized the same as the viewport, so we can pass through that frame size for it. That just matches the size of the image. And our resource for that one is resources.images.caveground. We'll make sure we add this. So this .add child, adding in that ground. In our main.js file, instead of starting with new outdoor level, let's start with new cave. So I'm going to comment this line out. Main scene.set level, new cave, level 1. My bad, looks like my auto import didn't work. So on cave level 1, I'm going to say import level. Now we see the cave artwork being drawn. Now back in our cave level file, let's add some more content. First, I'm going to add in one of those exits. I've got it kind of to the left here. There it is. We'll add in a hero to this one. As soon as we have a hero around, the camera starts receiving that hero position change signal, and that's why it kind of shifted everything over, but you can see the hero's here, and he can walk around. That's really all we need to demonstrate the level switching, but for kicks, let's go ahead and add a new rod. Now we see a rod appear over there, so I can go over there and pick it up. That should all work. Now, currently, when we navigate to the stairwell, we step on it and we get that change the map log that we put in last time. That log is coming from the top level, main.js. Let's go ahead and remove that. And instead, we want to move it to our main game object. In fact, here we can clean up this file real fast. So we've left this file pretty clean. Let's go to our cave level. As soon as the cave level enters the scene, we'll bring over the lines of code that start listening for the hero to reach this exit space. We'll change the caller, of course, to be this, which is the level itself. We know we're in the context of cave level 1, and so maybe cave level 2 is next. So instructing the game engine to switch to cave level 2 could be something that happens in this callback. First, let's just make sure everything still works. So I'll go here, and we still see our log fire, change the map. So to execute our swap, we need our main game object file to call this set level method. Instead of cave level calling that directly on main, we can use our event system for that. We'll have our main game object extend its ready, grab the event system, and listen to a new signal called change level. That caller is going to be this, and we'll receive a new level instance, and we can pass that through to our this.setLevel, passing through that new level instance. That will cause the current level to get unmounted and destroyed, and then the new incoming one to be set as the new level. That will start drawing it, and then we should be switched over. So we need our individual levels to call this signal whenever we want to change to those levels. And for the record, it could be some kind of other event that changes level 2. It doesn't necessarily have to be this like exit space. As soon as anything in the tree fires off this signal, it'll go ahead and, load the new level. So it could be like you died and you're starting over, or some secret passage or something. Who knows? So our cave level has a dedicated stairwell. When we reach that stairwell, we know hero exits will fire. From there, we can emit a different signal. So events.emit. change level. Which level do we want to go to? For now, let's just go back to our outdoor level. So new outdoor level. So we reach the exit point. We're going to create a new outdoor level in memory and then pass that through with our change level signal. That will be received by our main.js, and then it'll get loaded in. So let's try it. Now we step on the space and we see our new level. Now our outdoor level also has a stairwell, but remember, it's not really wired up yet. If we go to that file, outdoorlevel.js, we're creating it, but we're not ever listening to that signal gets fired when the hero reaches it. So let's go to our cave level and copy over our ready method. Same idea, just we're in the outdoor file now. Hero exits is fired. We react to that by changing the level. If you wanted to restart the level, you could pass in the same level that already exists, or we could say a new cave level. So now our stairwell should go back and forth. So I'll go over here, I'm outdoors, go in here, set up the cave. Now we could build out this whole world by linking a bunch of different maps together. In this section, we're going to be able to define where the hero should start when a new level loads. So the problem we want to solve now is that the hero can change maps, and that's great, but it doesn't make a ton of sense. So when he steps in the stairwell, he's kind of in the middle of nowhere here. We want to be able to define where he should start in this new incoming map. And we can see the kind of that reverse case here. So when I enter the stairwell, I want to maybe appear like over here or over here, kind of near the other stairwell. In our code, let's go to cavelevel1.js. We're listening to this hero exit event, and then we are emitting a change level event. Let's pass some more information into the change level. So instead of just new outdoor level, let's get more specific on maybe some details we want this level to begin with. So I'll add a new object into the function call there. I'll include a new property called hero position. Similar to how we create a hero up here, we want to go ahead and provide an X and Y that the hero should start at. We can do that in the format of a vector too. So I'll just copy over some values here. We can make them exact in a second. And just to prove that it's working, let's make them kind of extreme. So top left corner, 1, 1. We want to do this for both of our maps. So let's also go to our outdoor file, outdoorlevel1.js. And at the bottom, new cave level, let's pass in a new object. That'll be hero position. Do the same kind of idea here. Now on the map side of things, we need to be set up to receive this hero position value. So we can start that with outdoor level. I'll go to the top to the constructor. Somewhere outside the class definition, I could say const default hero position. So say that we don't provide one, we can just kind of fall back to this one. And just for kicks, I'm going to copy over the same values we have been using. So that's 6 and 5. Into our grid cell helper, 6 and 5. We know when we call new outdoor level, we might be passing in some information here. So the argument for that could be like params, and then we'll default that to an empty object if we didn't pass anything. When we create the hero, instead of just passing in these values directly, let's make a different variable called const hero start. If we received a params.hero position, we should use that. But if we didn't, we can use our nullish check and default back to that default hero position. So no matter what, we're going to have an X and Y to work with here. We can go ahead and use that XY value in our new hero starting position. So hero start.x and Y. So again, now we can optionally pass a starting position to the map, and the hero will start right there. If we don't, and the game's just booting up or something like that, we'll default to that default one. Okay, so let's see if this works. When I step into the stairwell, the hero starts, but he starts in this really extreme position. Again, this is 1, 1. We kind of did that on purpose. Now we can make a more realistic value to maybe put him like over here. Back in cave level, let's go ahead and adjust our, extreme position to be a little bit more realistic. I'll say 3 and 6. Let's quickly wire up this idea for the other map as well. So at the top, we're going to have a const default hero position. It's a new vector 2. We'll copy over the same things we have been using. Again, these aren't super meaningful, but just something to work with. When we create the cave level, we can go ahead and pass in some params. And again, we default to an empty object there. Before creating the hero, let's make a new value called hero start. If our parameters have a hero position, we'll use that. Otherwise, we can default back to default hero position. And again, we'll just pass through that XY right here. Hero start.x and hero start.y. Great, now we can kind of configure where the hero starts in both maps. So for placing where we want to go, let's go ahead and look at our outdoor level. We know that we're going to place a exit at position 6, 3. So let's maybe go ahead and start the outdoor level below that. So we'll say 6, 4. And we'll go ahead and do that same idea for the reverse. So we know that the cave level has an exit at position 3, 5. Let's see this working. The game loads and I start in the default cave position. Cool. I'll enter the stairwell. And now I'm kind of positioned near the stairwell on the other map. I'll re-enter the stairwell. And now I'm sort of near, I was kind of one space off, but I'm sort of near the stairwell. That value could be tweaked to be whatever you want. When we start a new cave, we want to be at 3, 6. My bad. Now, we do have one little problem in the system, and that's if I start the map at like a really extreme position, a really extreme different position, so say like 16, 4, we'll see that when the hero enters the next map, we get like one frame of a flash. I don't know if you can see that. Let me do it one more time. I'll try to highlight it in the editing too. We get one frame of flash where you kind of see the old state at a really extreme position, and then the new state snaps into place. This is because the camera was over here, and then the new map loads, and the hero emits his new position, and the camera's like, oh shoot, I gotta like get way over there. And so we kind of see that jump. Let's smooth this over. So when the new map starts, the camera is right on the hero. Now on both maps, let's take that constant and save it to the class, this.hero start position. That way we'll be able to reference this from the outside. Now in camera.js and the constructor, we can go ahead and subscribe to that same change level event. We'll be able to use this signal to snap exactly to where the camera should start. Now this idea here where we get a new position and then we do some math to kind of position the camera around it, it's tied to a new hero position coming in. Let's go ahead and move this code so that we can use it in more than just this one place. On this class itself, I'll make a new method called center position on target. That's going to take in a position. And we can simply move all of these lines, grab them all, paste them in here, make some modifications. Instead of being tethered to the hero's position here, we can just use whatever's passed in. So that's position.x and position.y. Up here, we can remove our old lines of code because we've moved them and go ahead and just offload that to our new method. And we'll pass in hero position there. And then when the level starts, we'll do the same idea. We want to center on a position, and we're going to use new map's hero starting position. Let's see if this works. Now I'll walk into the new map. And on frame 1, the camera snaps exactly to where the hero starts. See that again, walking through objects. Now from here, there's still some work we could do to maybe smooth over the level transition, maybe some kind of crossfade or something. But still, even without that, we can use this technique to really stitch levels together. You could also use this to create different entryways into the same map, like maybe different doors start you at different places. In this video, we're going to add another character NPC to the scene. In doing that, we're also going to allow the NPC to take up space so the hero can't walk on top of them, and we'll add some Y-sort drawing as well. We're going to start this just by getting our NPC on screen. So I've added this new sprite sheet to the project, night sheet 1. It's pretty simple, just 2 frames. But we're going to go ahead and use this to show this first frame of the night. Now to load our new sprite sheet, we need to go to resources.js and add it to our project. So I'll say NPCs here. We might have multiple as we go, who knows. We'll call this one night. And here's the path to that sprite sheet. Let's create a file for this game object. Objects, I'm going to create a new subdirectory called NPC. And then within that, I'll make a new file called npc.js, capital N. I'll collapse this to give us some more room. Let's export our class NPC extends game object. We'll do a constructor, and pretty standard stuff at this point. We're going to take in an X and a Y. We'll pass that X and Y through in our super call to the base game object to create a new position. So we'll use the X and Y as a vector 2. Similar to the hero, the NPC is going to be one of those compound game objects where he's going to have a shadow layer and a body layer. So within the constructor, here comes the shadow. We'll create a new sprite using the shadow image, frame size 32 by 32, and we'll position it kind of offset. This is the exact same thing we saw with the hero object. Now, right after that, let's add a comment here. This is shadow under feet. We can create the actual body for the knight. For that, we'll say body will be a new sprite. And we're going to copy over a lot of the same configuration that the hero uses. A couple differences, though. First, our resource is, of course, going to be our new resource, our resources.images.knight. As we go, if we do add more skins, we could add some logic here to swap out which image is used. As far as our sizing values, just like the hero, this is 32 by 32. We have 2 frames horizontally, 1 vertical frame. In a similar way, we'll offset those body pixels so that the body is positioned relative to the cell that the NPC is standing on. We'll add this as a child. So this .add child body. And now we're ready to add this NPC to a map just to see what it looks like. We're starting the game on the cave map still, so let's just hop over there. Kind of before that wall set, I'll say const NPC is a new NPC. I'll grab that default starting hero position and change it. So we'll start this NPC at 5, just kind of next to the hero. Then we'll add it to the scene. So this .add child, passing in our NPC. Now we can see what it looks like. Now when we load up the game, we can see the NPC looks there and he looks good. We have some problems, and one is which the NPC doesn't really take up any space. So the hero can just walk on right on top of him. There's also this layering drawing problem happening where if the hero can stand up here, that looks okay. But if the hero goes in front of him, then he's being drawn kind of funny. The knight's always drawn on top. So 2 things we want to add to our system here. One is the ability for the NPC to take up space, so the hero cannot walk on top of him as if he's a wall. And secondly is that Y sorting drawing kind of feature. Let's start with him taking up space. So let's go to our game object base. And at the top in the constructor, we're going to add 2 new ideas. First is this concept of being solid or not. So this .is solid. We can just default to false. Most game objects won't take up space. But the ones that opt into that, we can flip this to true, and then we'll add some collision checking for that. The other idea is going to involve drawing. So say some game objects have this .draw layer. We can just kind of assume default behavior here, where we want to draw things in order that they appear on screen, so by their Y position. Other game objects might be a little special, like this exit tile. The exit tile, we always want it to appear on the ground, on the floor. And so we might be able to assign it to a certain layer, and it always gets drawn underneath everything else, no matter its Y position. So we'll come back to this later, but for now, let's pursue making our NPC solid. We'll simply go to our npc.js, and somewhere in the constructor, how about at the top, we'll say this .is solid is true. When the hero's checking for collisions, we need to go ahead and check for that solid flag too. So in the hero file, at this try move method at the bottom, we have this one check that's kind of checking for dedicated walls. Let's go ahead and break this out a bit. So first, we'll move that check to a constant. It's is space is free. We can move that here. replace that if check with the constant. So now it's effectively the same thing, just a little refactor. We'll add another check that says solid body at space. And for that, we can grab our parent's children. So this.parent.children, and we'll iterate through them with find, searching for one specific match. So we'll return checking that the child is solid. So most of the time it's going to be false, like immediate disqualification. But if it is an NPC or anything else we make solid later, we'll check that one. We know that it's solid. We also want to check that the position matches that potential next X, next Y that's being checked here. So we'll check our next X against c.position.x and same for Y. So in our if check, we can say you're allowed to move there if the space is free and there's no solid body at that space. So no solid body at that space. Let's test this. So now when I load the game, the hero can walk as normal, but he cannot go through the NPC because that body is solid. It's finding it. I'll go around the other side here, see if we can go through that way. We can't. Nice, so this is looking pretty good. We still have this drawing problem though. Like see how the hero's head is cut off in this funny way? Let's go ahead and fix that now. Now the effect we want to achieve here is basically instead of just drawing every child in the scene in order, we want to go ahead and sort them first so that the ones with a lower Y value, or ones that are, higher up on the screen, more north, if you will, get drawn first. And then anything more southern gets drawn after that. Currently, we don't really check the position when drawing. We just blindly draw them. Back in our GameObject.js class, let's find the spot where we draw. Here we have this recursive draw method. It iterates through all the children. Instead of just iterating through the children like this, we want to get back a sorted list first. Right under this draw method, let's make a dedicated method for getDrawChildren ordered. We're going to build the default behavior of the game object to sort by Y position, but in the event that a different game object didn't want that for some reason, they could override this method. First, let's take this.children, but surround it with the spread operator. So new array, spread operator. This is going to make a copy of it. We're trying to just sort through these children and draw them in the order that we want, but we don't really want to modify the children list. And as soon as we do this, .sort, that's going to modify the original array. By surrounding it with a copy here, we're kind of creating a new copy that we can safely sort, and it's not going to have any weird side effects or anything. When we sort, we get back A and B, comparing two things. We want to return either 1 or -1 to sort the array properly. So we'll look at A's position.y. If that is greater than B's position.y, we'll return a 1. That's going to move it further down in the drawing order, so it draws on top. Otherwise, we'll say -1. That's going to move it towards the top of the array, so it gets drawn earlier. We'll take this method and call it when we're about to draw all of the children of this game object. So instead of this.children raw, we'll go ahead and use our method, this.getDrawChildren ordered. That'll give us back a sorted list that we want to iterate through and draw. Now the game is running and the ordering looks good. Like the hero is, in front of the knight there, behind him there. So that's good. That kind of brings the whole thing to life a lot more. We have this one problem though, and that involves this exit space over here. If I walk from the north, you'll see it layer above the hero for just a second. I'll try to pinpoint that in the editing. We want to make sure that this exit space is always on bottom under the feet of the characters, no matter what. So let's go to our exit file. And in the constructor, we can say this.drawLayer, which again is usually null, but we'll opt into a specific value here. And we'll say it's a new string called floor. Back in our game object file, let's expand and add one more check to this sort. We'll say if B's draw layer is floor, then we always want to return a 1, no matter what. Don't even compare it to whatever it's being compared to. Just know that we want that on bottom. With this in place, any game object that opts into floor as the draw layer should be drawn on bottom beneath the feet. So we're walking, and now I can step on top of the stairs, and no matter what, the hero will always appear on top. Now we have some more compelling layering happening, and the NPCs can take up space. The next step is to make the NPCs be able to talk to us. In this section, we're going to add text to our game using a TTF font file. Now, as a first step on getting some text on the screen, I've added a new asset to the project. That's textbox.png. It's just a nice little background that the text is going to lay on top of. In this first section all about text, we're going to add some dialogue to the screen, and we're going to use a regular font, like a TTF file, the same kind of thing you load into a web page to, specify whatever font you want to use. There are two-ish major approaches to getting text on the screen in a Canvas project like this, and so that's the first way, using a regular old font. So we're going to start with that. Now, this is good for our backdrop, but we also need to add a new type of public file. I'm going to make a new directory under public that's called fonts. I've copied over two files into this font directory. The first is a TTF file, so retrogaming.ttf, and with it, I've included a .txt file that just links to the crediting. So if you go to this URL, you'll see the font I'm talking about. If you see a different font you like, you could, of course, swap that in here instead. So let's load both of these assets into the project. I'll go to our typical resource.js and add a new kind of section here. Call this maybe HUD or something like that. We want to go ahead and load in our new sprite. That path looks like this, text box. Next, we want to go to our project CSS file. We haven't seen this in a while, style.css. Remember at the very beginning, we put a couple things here. We're just going to add one more block, and this is a font face block. This says I want to load a new font. It's going to be called this, font retro gaming, and we give it a source. So we'll link to our fonts and then the TTF file. Our Canvas drawing code will then be able to reference this font by the name here. We'll see that in a second. Our text box on screen is going to be another game object. So let's go ahead and create that too. Close all these files. In here, I'll make a new directory called just text box, and then same deal. Textbox.js. We'll add a constructor. We'll start with an actual string, like the text content that should go in this text box. So I'll say this .content is a string, like, hi, how are you? Next, we're going to fire up an instance of that new text box backdrop sprite that we created. So this .backdrop, we could call it, is a new sprite. Our resource will be our resources.images.textbox. And then we need to provide the frame size. This particular sprite size is 256 by 64. Now, similar to our sprite, we want to go ahead and extend our draw image method and kind of overwrite that with a very text-specific implementation. The first thing we're going to do is grab our internal backdrop image, this sprite that we created up here, and go ahead and just draw that to the same position that gets passed into this method. So let's draw image. We'll pass through the context and the position. Let's close this here. I'm going to pop over to main.js and kind of up where we have some of these global-ish instances. I'm going to create a new instance of our text box. We're just going to get it on the screen so we can see it and work with it. Later, we're going to massage it into launching at the correct time when you talk to an NPC and all that other stuff. So I'll just say this .textbox is a new text box. And then in our foreground layer, just like we did with the inventory, we can go ahead and manually kind of draw that. So this .textbox, we'll draw, and same deal, passing through that context and a position. Now we see our image appearing on the screen. It's pretty big, and you can see that it stays pinned to that top left corner as I walk the hero around. So that's good. This position's not that great though. We want to go ahead and move it so it's more like down here-ish. In our textbox.js file, in our super call, we'll pass through a position to use. So we're just taking that top left corner and moving it down a bit, 112, and over to the left. With this in place, the text sits on a nice kind of bottom center spot on the screen. Now let's fill this thing with some text. First, I'm going to bring in some lines that set up the context for our text drawing. So we'll set the font 16 pixels using that same name that we put in the CSS file. Then just some basic housekeeping things. We want to make sure text align is left and our baseline is on top. And we're going to set the fill color to be white, so the letters will be white. Next, I'm going to bring in some values to sort of configure the way we want the text to appear on the screen. So by that, I mean we want each line to be 250 pixels wide at a max, vertical spacing of those lines, padding left and padding top, like where we should start the cursor when we start to draw text. These are just values, of course, they're not being used yet, but we'll use them as we go. Now for absolute starters, let's go ahead and get some text drawn to the screen. So I'll grab the context and use the fill text method. So this is going to take in the string that we want to draw. So that's our this.content. Then we want an XY position where that cursor should start. And so our X is going to be our draw position X, which again gets passed into the method, but we want to go ahead and add our padding left to it. So this is just going to be nudged to sort of start a couple pixels in within that frame border. For our Y, we can do the same thing. Draw position Y, adding in that padding top. Now we see our text appearing. You can see that it starts, 10 pixels in. It draws. It's got a little bit of a blur to it, and we're going to discuss that in a second. But it does look like it's using our font correctly, so that's all good. And if I resize the window a bit, you can see that it kind of scales appropriately also. Now let's make this text really long. So instead of just this, I'm going to add some more content to it. Maybe, make it kind of crazy. At some point we have a practical page size. I'm not sure if that's going to hit it yet. Let's maybe just start with this much. Now we can see that the text kind of goes through the edge of our backdrop. We want to make sure that it wraps when it runs out of room here. Unfortunately, things like text wrap and that kind of thing aren't really baked into Canvas. We have to get pretty manual and instruct exactly where to draw each word. Back in our code here, we're going to kind of flesh out how this part works. Instead of just drawing our raw content string, we're going to go ahead and split it by the space character into different words. So this will give us an array of just word segments. Line is going to be the actual string that we end up drawing to the canvas here. And we're going to conditionally kind of add characters to it if we have room in this line. If we don't, we'll start a new line and bus that to a different Y position. So first, let's iterate through each word. We'll create a new variable in here called testLine that takes our current value and then whatever word that we're iterating on now and add a space character to it. This will give us a nice substring to work with. From there, we can use a Canvas feature called measure text. So we'll save that as metrics, context.measureText, passing in that string that we want to use. So we haven't actually drawn it yet. We just kind of know stuff about it, including how big it is. So we'll say width, test width is going to be our metrics.width. Now I'm going to bring in some code here and we're going to talk through it. So if the line we're trying to draw is greater than our max width, and this isn't the first one, we want to go ahead and move our cursor downwards. If we do have room for it, then we're good to just use testLine as line. That's the segment we were testing. And then again, we'll go ahead and do our fill text to draw everything at the specified position. So essentially, when we get to the end of our max width, we should have a nice break, and that should start drawing again, but at a further down Y position. Now when it gets to the end, it breaks to the next line, and that's a lot better. We can also play with the appearance of the text a little bit. For example, if I set it to maybe a smaller size, like 12 pixels, we can see we can fit more text that way. Now the text is blurry, so let's talk about that. The way this project is set up is that we have a pretty small canvas. Remember, it's only naturally about 320 pixels wide, and we're taking that and we're scaling it upwards to cover as much browser space as we have. That means everything that we're showing is actually very low resolution, and the browser wants to anti-alias the font so that it blurs the edges to kind of smooth over the printing of it. This approach makes a lot of sense if we had larger art. Say we were taking our characters and maybe scaling them up larger than they actually are, rather than scaling up the entire screen, which is the approach that we've taken here. So in your project, if you're using something like the scaling feature of a sprite to maybe have a larger canvas, like 1024 or something like that, and draw larger characters to it, then the text is going to look great. This technique will work fine. Oftentimes, low-resolution pixel art video games use a different technique for printing text to the screen for this very reason, and that looks more like creating a dedicated sprite sheet, where every character in the alphabet has a sprite frame associated with it, and we dynamically stamp each character according to the string that we want to print. That allows us to have fine control over the crispness of each letter. It also allows us to bring kind of fun custom lettering in the form of a sprite sheet that's really easy to edit without having to create an actual like TTF font file. So because this project is sort of rooted in low resolution, in the next section, we are going to swap out this system with that system. But the good news here is that if you want to pursue like an actual font file, TTF, and this works with your setup, this will be great. In this video, we're going to add text to the screen using a pixel art sprite sheet. We're going to need a different type of sprite-based text box to replace the previous text box that we created that uses a regular font. To do that, I'm going to need two assets. First is this new sprite sheet here called Sprite Font White. Notice all of the white characters in lowercase and then uppercase, and then we have some numbers and then some special characters. It's worth noting you can make different variations of this by changing up the appearance of the letters to be kind of whatever aesthetically matches your taste, or changing the color, or maybe making, different versions of the font. You can go wild with this, but I've just given us a nice default. In resource.js, we also need to make sure that this asset, the sprite asset, is loaded into the project. So I've added that here. Now remember, in main.js, we are currently creating a fresh instance of a text box right here in the constructor. We are going to replace this class with a different type of class. That'll be more like sprite text string. Still a string of text, but we're going to make it up with a combination of sprites. This, of course, does not exist yet, so let's create it. New object directory, sprite text string, and within there, we'll create our new JavaScript file. Just as before, we'll create a new game object. Let's make sure this is getting used in main.js. We need to make sure that import is right on. Get rid of this old line. When we create our text string here, let's give it some content to use. So we'll pass a string into the constructor, and then on the other side, we can receive it. That's our string. We can accept it here or just default to something. Close this for space. Even though our text box is on the screen, it doesn't really look like anything yet. So let's fire up that same backdrop that should sit right around here. Create a backdrop. Similar to our font-based text box, we're going to go ahead and extend that draw image method in the same way. So we'll extend our method here. Let's go ahead and draw that backdrop. We'll also make sure that we position this game object in a place that makes sense. Now we have it rendering pretty much the same as the other version. Let's go ahead and start adding our pixel text. If we take a look at our sprite letters here, again, we have one image and there's a bunch of different frames. We've got like 26 times 2 and then all the numbers and then, some special characters too. Instead of like manually creating each frame number, like this is going to be frame 0, 1, 2, etc., we're going to write some code that automatically loops through this whole thing and generates the frames for us. We also need to provide how wide each character is. See, characters like this A are about 5 pixels wide, but there's skinnier ones like I. There's super wide ones like this capital W. We're going to need to know like how wide each character is so that when we're printing each one, we can space them out properly. Now in our directory where we keep this sprite text string, let's go ahead and make a neighboring file. We'll call that sprite font map. And it's worth noting, we're just going to make one font here, but if you want to have multiple types of fonts in your game, maybe that get switched to in different contexts, you could create one of these files for each font that you have, but we're just going to start with one. Two major things we're going to do here. First is the widths of each character, and next is the frames. Let's start with the widths. Our default width for each character is 5, and again, this is just kind of how I designed each letter of the sprite sheet. If you're using skinnier letters or wider letters, you can go ahead and change this to whatever's needed for your asset. We're basically going to assume that every character is 5, but we might have overrides. And those overrides we're going to keep in a JavaScript map. So we'll say width is a new map. So like we said before, we could take our width map and set our I character, lowercase I, to be only like 2 wide because it's really skinny. And similar, like our capital W, that's a really wide one. That's actually 7 pixels. This is going to come in handy when we start stamping out each individual letter. Now, being honest, I and W are only 2 of many cases we're going to have. I've pre-prepared them, and I'll paste them in now. To my eye, this looks about right for each character in the font. Again, feel free to adjust these however you need. To actually utilize this width map, we're going to create a function. So we'll say export constant get character width. That function is going to take in a character string, just like a single string, like a W or a space, an apostrophe. That's going to look in our width map and get the key that matches that character. So if that finds a match, it's going to return like 4, 3, 4, any of these overrides that we have. But if it doesn't find anything, we can go ahead and assume our default width, and that's going to be our 5. Now we're exporting this function so that we can use it when we start stamping out the letters. Before we do that, let's move on to the frames part of this. Similar to widths, we're also going to create a dedicated frame map. That's a new JavaScript map. This is what we want to populate with like 0 for lowercase a, 1 for lowercase b, 2 for c, scanning through the whole image just like we've seen before. So if I pass in lowercase a, I want a 0 back. If I pass in a lowercase b, I want a 1 back. To achieve that, we're going to have a couple arrays here, and we're going to iterate through all of them. Now I have a long string of characters that matches up exactly in the order that the characters appear here. And of course, it's just the alphabet, nothing crazy. Then I have the same thing in uppercase. Then we have all the numbers, then a space character, 2 underscores, and these simply just take up the space for a couple empty frames here. See how there's 3 empty ones at the end of this row? We need to make sure that the array looping compensates for those. And for what it's worth, you could fill these in with other characters if you didn't want blanks there. Finally, we have our special characters. I'm going to join all 3 of these strings together so we have one monster string. Breaking it out this way just makes it more readable. Then from that monster string, we're going to split it into individual characters. So now we have an array of every single character in our sprite map. We'll iterate through all of them. So we'll start at lowercase a, that'll be 0, lowercase b will be 1, etc. So we can just use that index as the value in the map per each key. So we'll grab the frame map and set the character is the key to be whatever the index is now. So when this runs, it's going to automatically populate our frame map, so we don't have to manually do that. If you end up adding any special characters or anything else to this image, you're going to want to make sure you add it to the array at the matching spot. Finally, before we actually fire this thing up, just like we had on the width part, we need to create a function that can be used by our external callers. So in the same way, we'll make a new one called getCharacterFrame. It takes in a character. It's going to look up the key. It'll give us back a number to use for the sprite frame. And if for some reason it doesn't find anything, we'll just default to 0. So if you start seeing random unexpected lowercase a's appearing, that's probably because the code is defaulting to this 0. So you want to check what character you're sending in and see if we have a match in the frame map. Now that we have all this stuff in place, let's go ahead and start using it. So back to Sprite textstring.js, we're going to make some jumps here, but by the end of all this, we're going to end up with something pretty sweet. Similar to how we did the regular font-based text box, we're going to need to know how wide each word is. That's going to let us know when we need to break to the next line when we're stamping these things out. So just like we did before, we're going to take our content and we're going to change it into an array. Each entry in the array is just going to be a single word of text. And then when we print them, we'll iterate through the words and then add in this text space. So we'll save the words, this .words, so we can draw them later. We'll grab our content and split it. This time we're going to split by the space character. So that'll give us an array like default text. we're going to map through each word and transform it into something else. Specifically, we're going to end up transforming it into a word width, so we know how wide it is, and then also an array of characters. And those are going to be individual sprites. We'll iterate through the sprites as we're drawing and stamp them all to the canvas. So to figure out this word width, how long is this individual word in pixels, we'll start with a counter. So we'll say word width is 0. Then we're going to break out our word into individual characters. So we'll grab the word and we'll split it, splitting with an empty string there. Then we'll iterate through each character itself and grab the individual character width. And remember, we have a map for that. So that's why we set up that previously. So get character width, we'll pass in the character that we're iterating through now. That's just a single letter, single character. And we'll get a number back. Remember, it's going to default to 5, but if we put any overrides in, then we might get some other than 5. So whatever it is, we can add it to our word width. We need to capture the character width separately because we're also going to need to know that when we draw, because we need to know like how to space the next character away from this one. So we need to know how large it is, how wide it is. We're assembling our characters here. And so for each character, we want to know how wide it is. So that's our width, is our character width. Oops, move that up here. And for each character, we also want to create an instance of a sprite. So that's going to be a sprite, will be a new sprite. We want to pull this from our letter image. That's the image that has all those letters baked into it. So that's resources.images.font_white. Again, if you had multiple fonts, you could bake in logic to like swap this out with whatever font you're trying to draw from. That sprite sheet is arranged in 13 frames wide and 6 frames vertical. Remember, you can tweak these if you're using a different font asset or you've made any changes. The last thing we need to provide is a frame, and that's the frame we want to use. Remember, like 0 for lowercase a, 1 for lowercase b, etc. And we have a helper for that. It's get character frame. We'll pass in that character. And now we're leveraging our sprite system to just show one of these individual characters. Pretty sweet. Now there's a lot going on here, so let's kind of break it down one more time. So first we want to create an array of words. We're going to break each word into single characters. Then we'll measure each character so we can come up with that total width. We also need to know the width of each one. Then we'll grab our subset, which is what Sprite helps us with. Finally, this whole word is going to be return a length and a list of characters per word. This is all saved to the class as this.words. So when it comes time to draw, we can go ahead and iterate through that. And that's what we're going to do next. So down in our drawing code, let's start to fill this out. Some more room here. First, we're going to start with our configuration options. This is going to be like our line width and our vertical height and all that kind of line letter spacing stuff. We have top left starting point. We have how long we want each line to be, and this kind of lines up with the asset we're using, the backdrop. And we have a pixel amount for how far down we should space the cursor when we break to the next line. Speaking of a cursor, we can take this X value of the whole object and this padding left value to come up with our initial value for the cursor. So we'll have a cursor X and cursor Y. It'll be a draw position plus our padding. Do the same thing for Y. And by cursor, of course, I mean, just like we see here, we might have 3 characters we want to stamp, 1, 2, 3. Our cursor is going to start here, move to the next one, move to the next one, move to the next one. When it's out of space, it's going to break to a new line and then start drawing right there. We're going to keep doing that. Okay, so let's iterate through our words. And before we get into any actual line breaking stuff, let's just see it run off the edge of the screen. We're going to iterate through all the characters in this word. From there, we're going to grab out our sprite and our width. We'll create a character offset, which is basically the distance from the left side of a cell to where the character itself actually starts. So this is a grid of 16 by 16. The characters are kind of in the middle of each 16 by 16 cell, so we need to get rid of this leftmost space that sits over here on each one. That's about 5 pixels. So we'll use our Sprites draw method to stamp this individual character to the context at that X position. And currently our cursor Y is never changing, but eventually that's going to be incrementing as we go. When we're done with this one, we're going to add the space of this character to the cursor X. So that's going to move it over, and then we'll add an additional space just for another little space between the character and the next character. Otherwise, they'd be butting up against each other like a cursive-y kind of look. You could adjust this to your taste if you're looking for more spacing between letters or if you want them to butt right up against each other. It might differ based on the style that you're going for. Okay, so now we're stamping out a single word. We're about to move on to the next word, and so we want to make sure that we move the cursor a space over. So we'll grab the cursor X and we'll just add 3 pixels to it. Without this, we'd see something like first word, and then the next word would come up and it would print it right next to it, as if it's all in the same word. But this line here is going to add a dynamic space between each one. Now when we check on this in the browser, we can see that it's working. We see our content, hello, there's a space between each word, there are individual spaces between each letter, and it looks pretty good. That lowercase t looks a little tight to me though, so let's adjust that. We'll go to our font map, we'll look at our case for lowercase t, and instead of 3, let's uptick it to 4. And now it's a little bit more spacey. So again, you can tweak this to your tastes. Now we don't have any text wrapping in place, so let's go ahead and break it by adding a really long string into the text box. In main.js, here's our content. I'm going to add some more words. Just duplicate this a couple times. Now we see it going way off screen. That's not good. So now we want to dynamically cut if we've run out of space on this line. So back in Sprite text string, let's go ahead and add some logic for using our width max and our vertical height to space down that Y cursor. When we're iterating through each word, we basically just want to, decide if we can fit this next word on this next line. So for that, we can just do some quick math. We'll take our current position and add the width of the line, like the max width that we want to go, and then we'll subtract the cursor X. That's going to tell us kind of how much space we have left to use. So if the space remaining is less than our word width, then we basically don't have enough room for this word. We want to go ahead and uptick our cursor Y, or add our line vertical height to it. So we'll grab our cursor Y, and we'll simply add our line vertical height. No big deal there. But our cursor X is still going to be kind of way to the right side, like at the end of this line. So we want to make sure that we reset it to basically the same spot that it started at. So we can just copy this initialization and move it into the same block. Then when we get to the end of the line, it'll kind of go back to the left and down and then start printing again. Let's see if this works. Here we can see the result looks great. We get to the end of the line and then it doesn't keep going over. It knows to break to the next line. So this approach is a little bit more manual because of course we had to create the whole font that gets used, but we have very precise control. The next thing we're going to do is a typewriter effect. So instead of all these letters just appearing all at once, we're going to stamp them one at a time. That's going to give us a nice dialogue, speechy kind of effect. In this session, we're going to utilize the game loop delta time to add a typewriter effect to our text box. Now, instead of just stamping all of these characters at once, we want to kind of dynamically show them one at a time. And so we're essentially going to start with a counter in this class. It's like, how many characters have we revealed yet? That'll start at 0. And then as time goes on, we'll add and add and add and add. And as that index goes up, we'll reveal another character as we go. But to take advantage of that flow of time, we need to make sure that this class is part of our game loop, which currently it's actually not. If we go to main.js, we can see that the text box is created in memory here, just right in the constructor, and then it's sort of manually drawn in the foreground, but it's not actually a child of this main game object. Because it's not a child, it's not going to receive that step flow like everything else does within main, all of the children of main. Instead of manually flowing time through or something like that, we want to rework the system a tiny bit so that this actually is a child and that any specified foreground objects get drawn on top, kind of automatically instead of us needing to do it this way. So if you remember, in a previous video, we set up a concept of a draw layer. So let's go to Sprite text string, and in the constructor, let's opt in to saying this.draw layer is going to be the HUD. And we're going to make the same change to our inventory. So inventory.js up in the constructor will also opt into this draw layer HUD, HUD. Now at the bottom of main.js, we have this dedicated draw foreground area. Instead of manually picking certain things to draw, we want to do it more dynamically. We want to draw anything that's in that HUD layer. So I'll add this loop here that iterates through our children. And if that child matches draw layer HUD, then we can go ahead and draw it during this time. So we can get rid of these old lines. Now that's a little bit more dynamic. But in our regular drawing cycle, when we're drawing just regular objects like the hero and the rod and the NPC and that kind of thing, we want to make sure during that time we don't draw any HUD items. But currently we don't really differentiate. We just say draw all the children you have. So let's make another dedicated method that's like draw objects. And that'll work just like this, kind of a dedicated area where we only draw the object layer. And for that, we can basically copy this idea over. And we'll say if the layer is not HUD, go ahead and draw it. Now in a more fleshed out system, we might get a little bit more advanced, like offering maybe as many layers as you want. But for our pretty simple use case here, this is a really good starting point. Let's copy this method and go over to our regular main.js file. This middle part kicks off that recursive process that draws any children within main scene. So instead of doing that, we can just kick off our draw objects method, passing through the context, and then essentially the same thing is going to happen. It'll draw anything that's not in the HUD layer. Later in the cycle, we get this draw foreground method. That's going to go ahead and take care of drawing our HUD items on top of everything else. Notice in the browser that the top layers aren't actually drawing yet, and that's because we need to make sure that they are children of the main scene. So if we go back to main.js, we're creating these things in memory, but we're not actually adding them as children. So we say this.add child to our inventory. That's going to get it in the draw flow and in the delta time update flow, which is really why we're doing this. We'll add both of these. And now everything works as expected. And those top layers stay pinned where they go. Now we're almost ready to implement the typewriter effect, but before we do, I want to better emulate the feeling of the text box dynamically popping up. Instead of having it just be here when the game starts, we want to better emulate what it's like to talk to an NPC, where you do some kind of action and then the dialog box pops up and then the typewriter starts. So in our main.js file, instead of attaching these things to the class, we really only had to do that before because we were manually drawing them in foreground. Don't need to do that anymore. We can kind of change how this works. So I'm going to grab these 4 lines and move them into our ready method. Instead of attaching to the class, we can just say const inventory. That way it just simplifies it a bit. And same with our text box. To emulate the text box popping up though, and having it kind of be more like a one-off thing, let's go ahead and just try a set timeout. So we'll wait like a couple milliseconds, not many. This is going to make the text box a little less permanent and better enable us to work on kind of like dynamically putting it on screen and then taking it out later. Now in the browser, everything should basically work the same. We'll just see a little bit of a delay before that text box appears. So that's working great. Now we have a more realistic demonstration of a game object just appearing on screen and still being in the flow of everything. So let's go into our sprite text string and we'll start utilizing the delta time that's flowing through. So we can extend our step method. We have access to delta time. We'll come back to this in a second. First, let's add some new variables that we can use. So this is for the typewriter effect, and I'm in the constructor here, by the way. There's just kind of a lot going on in here. Bottom of the constructor, bring in some values. First is showing index, and that's going to start at 0. That's basically how many characters are we showing in the typewriter effect right now. It's going to start at 0 and basically work its way up to the max. The max is how many total characters we're showing in the text box. Next, we want to know how much time should pass before we show another character. So that's going to be our text speed. 80 feels pretty good to me, but of course you could tweak this however you want. We're going to keep track of this 80 in a different counter. So time until next show, this is going to start at 80 or whatever our text speed is and slowly decrement as the delta time goes. As soon as it hits 0, we know we can reset it to the top of text speed and increment this value by 1. So that's how the timing of this all links to the delta time in the game loop. So now we can actually implement our step code. So we'll grab that time until next show and we'll subtract the delta time. So that's going to slowly work its way down to 0. If it hits 0, then we know we can increase that showing index. So that number is going to keep going up. And then we need to reset our time counter. We'll reset that to our text speed. Finally, we just need to put this showing index to use. And so we'll go down to our drawing code. We'll make a new variable down here called current showing index. And that'll start at 0. That means we're showing 0 of all the characters. As we're iterating through each character, we can check how our number compares to our current rule of how many we should be showing. So as our delta time flows, this number is always going up, and that's going to allow us to reveal more characters. The last thing we need to do is increment our manual counter here. Because our characters are all broken up into different words, we kind of need to manually keep track of that above and increment every time we add a new character. So we can do that after we space the cursor out. So we'll add 1 there. Let's see this working. The text box appears and starts this typewriter effect. So that already makes it pretty conversational, kind of cool. We can play with this a little bit too. For example, we could increase the text speed. So if we made it a smaller number, it's going to roll out way faster, like frantic speaking. And then we could do the opposite for slower. We can also play with adding more indexes to show. Like if we add 3 at a time instead of 1, that's kind of a cool retro effect also. So there's a lot of flexibility, a lot of stuff you can do with this. Now this is a really nice effect, but next it needs some usability. For example, when it's rolling out, I want to be able to hit the space bar to jump to the end of it, so I don't have to wait for all this to roll out. That's going to segue nice into us needing to wire up a space bar control to talk to the NPCs anyway. So next, we're going to move on to adding some more features to our input control. In this session, we're going to build input handlers into our text box to enable starting, skipping, and destroying of an interaction. Let's start out by going to our input file. That's input.js. And this file so far is great for handling arrow keys like up, down, left, and right, but it does not yet do action keys like enter, spacebar, or maybe any letters we want to press. So let's go ahead and add that capability. In the constructor, I'm going to go ahead and add 2 lines. This.keys will be an empty object, and this.lastKeys. Many game engines will give you the option to check, hey, is the key held down right now? And also, hey, was the key pressed once? So maybe you just want to do something on that very first frame that it's pressed. We're going to be able to do that same kind of offering by comparing our keys to our last keys. So in our key down handler, we can go ahead and mark that a new key has come in. So that's going to be this.keys, and then whatever e.code came in, we can just set that to true. And we'll do the opposite for key up. So if we lose a key, let's just make sure that that's marked as false. In this class, we're going to go ahead and add an update method. So how about under that getter, we'll add an update method. This is going to be called every frame, similar to step, but it doesn't really involve delta time. That doesn't matter. We can go ahead and redefine our last keys. This dot last keys is going to be a new copy of whatever keys is now. We can add a dedicated method for doing that little logic check. Looks like this. Given any key code, we can assume it has not been pressed, but if it does exist in keys and did not exist in our last keys, we'll go ahead and flip it to true. We'll return it either way. Now, it's important that this update is called after all of the game objects do their step methods. That's because the game objects are going to be able to use this method to check for a new entry in this .keys. But as soon as they're done checking and that one pass is finished, we want to go ahead and update last keys. That way they have exactly one frame, one opportunity to check, hey, is this thing newly here or not? But anyway, if this came too early, then these two values would be the same every single time, and then we'd never get a good value here. So to make sure the order happens correctly, let's go to our main.js file with lowercase m. We'll find the order of events, this update method that's called. We run the step entry on all children involved, but once that's done, we can go ahead and grab our input. We'll always have one, but let's just assume maybe we don't. We'll do an optional chain on there. We can run .update. So the keys will be refreshed on every single frame. And again, the delta time, stuff like that doesn't matter here. Now with this in place, any game object's going to be able to ask, hey, is there any new key that's been pressed just now? Like just pressed for the first time. So let's go to our hero and kind of see that working. Say that we're in business as usual and we're not working on this item pickup thing. We can grab our input from the root. So that's root.input. And for JS docs type helper, to help the editor out, I'm going to go ahead and mark it as type input. That's just going to help it auto-complete some of the methods. You can see if I type if input dot, here we have the method we just created as a suggestion. We can punch in a key code here like space. During that time, we can grab our event system and emit something like hero requests action. So that's what we can use to actually talk to the NPCs. Now if we just do some console logging here. In the game, if we pop open the console, start pressing the spacebar, you can see our action log appears. And if I hold down the spacebar, it still only fires that one time. So with this in place, we're going to be able to wire up a key press to skip through the typewriter here. So if we interrupt it by pressing the spacebar, it'll just skip to the end. So let's get that going by going over to Sprite textstring.js. We're going to modify our typewriter code just a tiny bit. Towards the top here, we want to know how many possible visible characters we're going to have to show. That way, if a input comes in while we're still rolling out and still working our way to that number, we can jump to the end. But then also, if it comes in and we're already at the end, that means proceed on. So if it's already rolled out, the first button press is going to end the text box. If it's not done rolling out yet, the first touch will warp to the end, and then a second touch will end the text box. We have access to all of the possible characters, but it's kind of nested within the words array here. So we're going to do some array magic to count all those characters. Make a new variable called final index. We're going to take our words and use array reduce. From there, we'll get an accumulator, and then whatever word we're iterating through now, we can basically return the current total of the accumulator. That's the number we're going to be building up as we count things. We'll add whatever that current word char's length is. And then we'll start this whole process at 0. We start at 0, we iterate through all the words. It's going to add the word character length, which is the array of characters, however many are in there, to that number. That number is going to be represented by accumulator as we go. And by the end of this, we'll have just one nice final total that's a number. Let's do that same kind of keyboard input idea right here in step. We'll grab our input from the root again, just like we did before. So root.input, the root is given to us right here. We can do our same type hinting just like this. Not a requirement, just a nice thing to have. So again, we'll check for that space key handler. If the current showing index is less than that final index, that means we have not revealed all of them. And so this would be a skip action. And then we can return here. Otherwise, we're done with the text box. That means we want the text box to go away because we've already read it. In this last case here, we can go ahead and use our event system to emit up some kind of signal that's like end text box. When one of these is placed, we'll be listening for this signal to fire. And once it's done, then we can do like our cleanup stuff. In this case, we're not quite done yet, but we do just want to warp the showing index to the end, so we can just increase the value without having to wait for all these steps to roll out. So we can just set it to this.final index. We're talking, and then I hit spacebar and it jumps to the end. If I hit spacebar one more time, it's going to fire off that end signal, which we're not yet handling. We'll use that to clean up the text box and get it off the screen. Also notice that you can walk the hero around as the text is still rolling out, and we really want him to be locked in place while anything like that is happening. So we can quickly add that feature to the hero, again, using the event system. So back to the hero, we can go ahead and extend his ready method that we're not yet using. So right under the constructor there, use the ready method. There are two events we can subscribe to. First is going to be the starting of a text box. So when this happens, we can set a lock on the hero. So this dot is locked is true. That'll be a new variable, a class level variable that we make. And then we can do the opposite here. So we use that end text box, set locked to false. And just to be sure, we want to make sure this lines up exactly with this. Yes, so end text box is fired from the text box. It'll go up. The event system will then rain it down to everybody. The hero will listen to that and then be unlocked. And then, we'll do the same thing when we launch a text box to the screen. We can default this kind of in our stateful variables here to false. And then simply in our step code, we really want nothing to happen while the hero is locked. So if this dot locked is true, just don't even do anything. So for the hero to enter the lock state, we need to fire off this signal when the text box hits the screen. Okay, remember down here how we're emitting an event for hero requests action? We can go ahead and use that now in our main scene. Under our change level handler, let's add a new on, so events.on. Here we can move our text box creating code into this block. So we'll move that down, get rid of our old set timeout here. Let's add some notes to clean up this file. I'm going to change this content for fun. Now the hero has requested an action. We're launching a new text box. Because we're launching one, we want to emit one of those like, hey, we've put a text box on screen. We could theoretically surround this in some logic because maybe there's nothing here for the hero to talk to or something like that. For now, we're just going to blindly let the spacebar launch one of these. We'll get more into looking up dialogue by location in the next session. For now, we can just emit an event here that says start text box. So the hero is listening for this. He's going to hear it. Then he'll go into locked mode. When it's all over, he'll hear the end text box event and then unlock. So let's try this out. We don't have a text box on screen until I hit the space bar. While it's up, I can't move the hero. The arrow keys aren't doing anything. I'm going to go ahead and press the space bar again, and that's going to end the event, and then the hero will be unlocked. But we don't yet have any instructions to actually destroy this text box instance. So let's add that next. As soon as we start a text box, we can add any listener for that end text box event here as well. So we'll create an ending subscription. We'll subscribe to that same event. So end text box. There's kind of a nice symmetrical action here. Like we start one and then the listener for ending one is right next to it. So this is the caller. When this happens, we can go ahead and grab that text box, which we still have closed up in a reference within this function here. So we have a reference to that very text box game object. We can run .destroy on it, so that'll get it off screen. And then with our event system, we want to make sure that we unsubscribe to this event. Once it's gone, it's destroyed. It's not going to fire again. We don't want to leave this function in memory anywhere. So we use our events.off method. Ending sub is going to be the ID that was created when we started the subscription. So we can just plop that right back into the system, and that will remove the callback. Let's try this. Now I'm walking, spacebar, can't move while the text box is up. I'll hit spacebar again to end the event, and now it's gone and destroyed, and I can move again. And remember, we can also quickly press space to skip to warp to the end, so that's kind of nice. In this session, we're going to create directional action triggers for launching dialog boxes. We'll also create character portraits and add those to the screen. Currently, the spacebar is just launching a text box whenever we press it, no matter what is around. Now we want to shift to actually dynamically looking up, hey, is there anybody there to talk to that the hero's facing? Also, the dialogue that shows should probably come from that person that we're talking to. So to achieve some of this directional detection stuff, we're going to add some helper methods to our vector2 class. Let's go to our good old vector2 class, and currently we just have the duplicate method. I'm going to add 2 more. First is matches. This is simply going to take in a different vector2 and tell us if the x and y is the exact same. So am I the same as this vector2? This is going to help us write some code that kind of reads more nicely than doing these checks inline. Next, this one's a little bit more complicated, but not too bad. We're going to add a neighbor check. So to neighbor, if we pass in a direction to this method, we want to get a new vector2 back that has been nudged in that direction. So we'll take our x and y and then dynamically apply the left, right, up, down directions to the x, y coordinates just on that 16 base cell. Then we'll return the output of that as a new vector2. Now we can use these methods in our hero class. If we go to hero.js, we're doing some spacebar checking right here. Let's go ahead and surround this in some conditions. We only want to emit this if we found an object to talk to, like facing the hero. So there's got to be something right where the hero is looking. We can call that object at position. So we only want to emit if we found an object at position, kind of working backwards here. That is going to be the output of a search. We can look at our parent scene and iterate through the children. We'll find the first child's position that matches our current position. But we don't want to just match our current position because that's where the hero is standing in now. We want to match the neighboring position. So that's where we can use our toNeighbor method. That'll give us a new vector2 that's nudged. And again, we need to pass in a direction here, up, left, down, or right. And so we can pass in our this.facing direction. Also, whatever we found, if we did find something, we'll go ahead and include that in the emit event. So the type is hero request action. We are requesting it from this object. Now, when we handle this in main.js, this will come through. It'll have an other object, or maybe with object is a better name for it. We want to check this object for a specific method that we'll add. So if type of with object dot get content, that's going to be a method that we're going to be able to implement on our game objects. If that exists, then we can go ahead and do this other stuff, which is creating the text box and all that. We want to grab the actual content. So we'll run the method. This is going to give us 2 things back. A string of what they should say, and then potentially a portrait. So what did they look like? We'll do the portrait part last, but first, instead of just, using the static string here for the text box, let's expand our Sprite text string class to accept more data. So I can say string is the content.string that'll be returned. And then we'll set up our portrait frame here. We'll get to this in a little bit. But if you want a really specific image to show within the text box, this is where that could be configured. Let's go to our NPC file and define that method. So NPC, put it right down here, get content. It needs to return that object. For one thing, a string like you found me in a portrait frame. This is going to be the index of a sprite sheet that we want to use. We're kind of working backwards here. This is going to be frame number 1 for this particular character. Before we test this out, let's make sure we go to our Sprite text string, and instead of just receiving a string only, we get some config. We can say that this is config.string. And if we don't receive one, we can default to this default text. We can even move this around a bit just for a little bit of cleanup. Okay, let's see if this works. When I hit the spacebar out here, nothing happens as expected. But when I walk up to a character and try it here, it does find him, and we get our string back that we expect. Now, of course, real quick, if we look at NPC here, we don't want to hard code this text inside NPC because then all NPCs would say the same thing. Instead, what if we went to cave map? And when we create the NPC, we can say this is like NPC1. We could pass in a string here to the constructor. Do the same thing with 2. And let's space him out a little bit, put him like 8 or so. Now our NPC can use that third argument and when we get this content back, we could say this dot text content. Now we'll have 2 on the screen and they say different things. So he says, I'm another, and he says, I'm the first NPC. So you can have as many characters as you want and they could say different things. What they say would be configured by the map. Okay, so why a method here? Well, the thing is, it's likely that you're going to want the NPCs to say different things at different times, maybe based on actions that the heroes completed, like story quest kind of stuff, or maybe they're taunting if they've lost a battle. It could be anything you want. At some point, though, you're going to need some kind of logic that's like, if you've done this, then say this. If you've done that, then say that. So this method could be a good home for that, where if you wanted to expand out text content to be more of a bigger structure, like an object or an array maybe, this method here could kind of search through that structure to figure out what to say instead of only returning the same thing. So I'll leave that for you to expand based on the type of game you're trying to make. But the idea is that you're probably going to want some kind of home to do that sort of searching and logic. And so this is a good pattern for that. The last thing we want to add here is a dedicated portrait that shows next to the text that's being rolled out. This can help us add some personality to our characters and kind of reinforce who's talking to who. So in the project here, I've added a new image, portraits sheet. Here's what it looks like. It's a sprite sheet, 64 by 16. There's some more invisible frames that go this way. But we've basically just got some faces of the characters. And if you had like bigger, more illustrated portraits, you could, of course, replace these with that and update the size. In our resources file, we'll make sure to load this asset into the browser. Now, all we need to do to really make this happen is to take our text box, nudge the text starting point over a bit, and then make some space for us to draw the portrait right here. In our sprite text string file, how about near the backdrop that's created? We'll make a new sprite. We'll pass in our resource, our portrait sprite sheet. That's currently designed at 4 frames wide and only 1 tall, which is the default. But the frame of who's talking is dynamic, and that's what's passed into this config object up here. So remember, we accept a string, and then we also accept a portrait frame. And if we don't get one, let's just say 0. And quick reminder, in main.js, this comes from the text box being created where we pass in a string and a portrait frame. Both of these things actually come from the NPC that you talk to. So different NPCs with different skins could provide which portrait should show when you talk to them. The last thing left to do is simply draw the image. Like I said, we're going to carve out some more padding so that we have room for our portrait to show. So I'll add like 20 pixels to this and a couple to this. That's going to move where our text displays. Right after we draw the backdrop, we can then draw the portrait. So this dot portrait, draw image. We're going to nudge it over from the side a bit, 6 pixels, and 6 from the top as well. Let's check this out. Now when I talk to someone, we see their portrait appear here. So that's kind of nice, kind of cool. And again, you could really flesh this out to be like a bigger image if you have one, or really make it your own. We could also configure this NPC to give us a different portrait. So let's go to our NPC file, and maybe instead of just a text content, this could be more like text config, which is an object. We can make this new idea of a text portrait frame. And then instead of hard coding 1 here, we could pass that through. So when we create an NPC, save in the cave level, instead of just a string here, we could say the content is, what you want to say. In a portrait frame, we could say this is 1, but for this character, for whatever reason, use 0. Maybe they have a nervous expression or just some other difference that you want to show. That way this can come from the outside. Now this NPC works the same, but this one shows a different portrait. Pretty nice. In this video, we're going to add a lightweight story system so that our characters can say different things at different times, based on what you've done in the game. Let's first create a home for our story flags to live. So I'm going to go into our project and make a new file. We'll call it storyflags.js. And similar to our event system, this is going to be a class. And we're simply going to export one shared instance for the whole game to use. And for a little demo here, we're going to start with just 2 possible flags. So we could say export const talked to NPC A. We'll just shorten that to A. And same for B. Internally in our story flags here, we're going to need a list. So in our constructor, I'm going to say this.flags is going to be a new JavaScript map. That's just going to be a nice key value store kind of baked into the language. We'll add a public add method that's going to take in a flag, which will be a string. And so that can simply grab our map, this.flags, and we'll use the set method on that, passing in flag as the key, and then for the value, we can just say true. So we'll set it up so we talk to NPC A, that's going to add the talk to A flag. That way our map will have talk to A as the key there, and then true as the value. That way we can look up talked to A later. Now the real core functionality of this class is going to come in this next method. We'll call it getRelevantScenario. This is going to take in a list of scenarios, and we'll be implementing those in just a second, and that's going to be an array. The idea here is that we want to iterate through all of the possible scenarios our NPC could say when we talk to them, and we're going to compare their requirements with our list of flags. Some outcomes might require that you've done something already. Some outcomes might be disqualified because you've already done something. We're basically going to be searching through this list and coming up with the best match. We're going to fill this out with the real logic later. But for now, just so we get some kind of return value, let's go ahead and return the first entry in the list. That way we can change our existing code to work okay with this kind of method, and then we'll come back and fill out the real logic in a second. Let's go ahead and modify our NPCs to own a scenarios list. So we'll go to our cave level. That's where we create the 2 NPCs that we have so far. NPC 1 and NPC 2. Right now, they only have one possible string that they do. And so instead of content being a string like this, we're going to change it to be an array. So content will be a list of objects Each object is going to have a string, a list of requirements, a list of bypassers, and then a flag that could be added. So let's talk through all of these real quick. String is pretty simple. That's just the content that's going to be used in the text box. Requires means any string in this list must exist in our list of story flags. This might look like did something 1, did something 2. That means this possible scenario is only valid if the hero has done both did something 1 and did something 2. If we don't have anything in the list, then there are no requirements. That'll be the case most of the time, probably. Bypass is kind of the opposite. That means if we have done anything in this list, like maybe we have talked to B, or going back to did something 2, then we don't want to show this. So that might be like the NPC telling you about an item you can go get. Well, if you know that you've already picked up the item and you have the story flag for it, then they shouldn't tell you that because, of course, you've already picked it up. We're not going to get too complicated with the system in this video series, but the system is pretty powerful. You can make some pretty complex combinations just using these two tools and create a game with a lot of social depth to it. If this scenario has adds flag defined, then whenever this text appears on the screen and we use it and we launch the dialog box, we are also going to add this string to our list of known flags. So with that in mind, we can get a little bit more realistic with this. So in this example, when we talk to this NPC, the first time we will not yet have talked to A because we haven't talked to them yet. So the system will move to this next option and check this. Doesn't have any requirements, so we know we can show it. When we do show it, we're going to add that story flag, talk to A. If we come back and talk to this person again, the check will match at this one because it only requires that we talk to A and we got it last time. So we should see I say this first, and then I say this second. Let's quickly fill out the second person too, just to convert him to the new way. So if we keep going here, we know that we need to change our NPCs a little bit to be able to support this kind of data structure instead of just the regular string that they have so far. So let's go to npc.js and find that get content method. Remember, we hinted we might end up adding story flag logic. Well, here we are. First, we'll look for a match. So we're going to grab our story flags instance and run that get relevant scenario. This wants a list of scenarios, which now we are passing into the NPC as content. And remember, at the top of the class, we save that as text config. So this .text content is the text config.content. So that's the list now. So we can simply pass in this .text content. Now, if we don't get a match for some reason, and that might be intentional, we want to go ahead and just stop here, not do anything. In fact, we'll return a more explicit null. Now, this might be unexpected in your game. It might make sense to have an NPC that you talk to, and if you haven't done anything or you haven't done the right requirements yet, they shouldn't do anything. Sometimes from a user experience, that can be a little confusing because it feels maybe like broken or, oh, that person doesn't do anything. So I'd recommend probably most of the time always making sure that you're returning something that doesn't have any requirements. Sometimes when debugging, it can be kind of confusing, like why isn't it showing anything? And it might be because there's no matches. So here we'll just add a warning. Just so if that does happen to you, you can kind of see the log happen. Maybe that's intentional, maybe not. So if it is intentional, you can probably remove this warning, but do what's right for your game. Now let's go ahead and make sure that this object is compatible with our potential match that we get back. So it should match one of those scenario objects. We can go ahead and add our adds flag so we can handle that later. So if we have a match.adds flag, we'll include that there. If we didn't get one, we'll just do an explicit null. Text content used to be a string, but now we want the match.string. Because again, each scenario has a string on it. That'll be the content that shows. Let's go ahead and just test this to make sure it works as expected so far. we talk to someone and we do get that string back. I say the second. Obviously, that's not correct because, we should only say that after we've seen the first message, but we're going to wire up that part now. So let's go ahead and start filling out our get relevant scenario method for real. So we'll go to that. Remember, right now we're just returning the first one. What we want to do is search through our list of potentials and return the first match. So the first one that has all the requirements and doesn't get bypassed, that kind of thing. So we're going to return scenarios.find. Find will iterate through the array, and then we can return true or false if we want to use that one. So the one that we're checking is scenario. Get rid of this old way. If we make it all the way through the function, we can go ahead and return true. So if we made it this far, this scenario is relevant. Now before, we're going to add some lines of code to potentially disqualify this scenario. So first we'll look for those bypass flags, and if we find anything, we can go ahead and return early. If we make it through those, we can go ahead and check that all the required flags are here. If any of those are missing, we'll again return false early. If we make it through all that, then this scenario is relevant. So first we need a list of bypass flags to work with. So we'll say bypass flags is a constant. That's going to be our scenario.bypass. But if we didn't provide one, just to make it optional, we can go ahead and default to an empty array. That can really clean up our configuration code so we don't need all these fields all the time. We're going to use a classic for loop to iterate through these. If I is less than the length of bypass flags, we'll keep going. Now we're on this flag, so that one will be our bypass flags at position I. If our map of flags that we set up at the very beginning has this flag, then we can return false. The classic for loop here enables us to return early from this check. So it's a little bit less clean to look at, but it can get us to where we want to go a little bit faster. Now let's go ahead and take the same idea. Sometimes risky to copy paste this kind of code, but we'll do it carefully. And if we make it this far, we want to go ahead and iterate through all the required flags. So I'll paste this and make sure that we select all of the instances, rename it to required flags. Those come from scenario.require, plural. So we iterate through each requires. The difference here, though, is that if we don't have the flag, then we want to return false, because we're basically asking here, hey, make sure that you have all of these flags. So we're iterating through the required. We're grabbing this particular required flag. If we don't have that one, we'll return false. Okay, one last thing to do before we test all this. Let's go to main.js. And in our get content handler here, we're going to handle the potential result that we get back. Remember, it's possible, like we talked about, that get content will no longer return something. And so if we don't find any content, we'll just stop here, return. Now we have a new case where our content might have come back with a story flag. So if it has that adds story flag, adds flag, we'll grab our story flags instance, run that add method, and pass in the flag. So content.adds flag. Let's go ahead and add a log here, just to make sure this is happening as expected. First, let's just make sure typos. Yes, we want adds flag, not add flags. Only adding one flag. Let's try this out. So we'll talk to our first NPC here. He says this first. We'll come back, talk to him again, and now he says something else. I say the second. This guy over here still says, "What a wonderful day." Okay, back in cave level JS, let's set this up to be just a little bit more fun. So our first NPC, he's going to be this kind of like grumpy person. I'm going to replace his content with this. So by default, he'll say grumble, grumble, another day at work. If you've talked to person B, which we'll add in a second, he's going to say this, but then as soon as you talk to him, it's going to add his flag, talk to A. And then this one will get bypassed if you've talked to him. So you should only see this once. I just can't stand that guy. Then after that, he'll default to this one. Pretty simple example. There are actually simpler ways to pull this exact scenario off probably, but this is just a demonstration on how you can use both features here. Now this guy, when you talk to him, he's going to add that flag, talk to B. By the way, you'll notice this is a constant instead of just a regular inline string. We set those up over here. That can be kind of nice to make sure you don't have any typos or anything, no magic strings. Ideally, the rest of our code would be converted to this kind of system, but for time, we didn't do it. For the story flags, it works really well. Okay, let's try this out. Talk to this guy first. He says, grumble, grumble, another day at work. Talk to this guy. What a wonderful day at work. Talk to this guy again. He says, I just can't stand that guy. He's too happy. Talk to him again, and he's just the worst. So with these flags, you can really add a lot of personality and storytelling capabilities to your game.